Hey folks, welcome back to another video. Today we're looking at question 2058. Find the minimum and maximum number of nodes between critical points. The way we'll be solving this problem is by basically having two pointers, one that looks at the previous node and one that looks at the next node, but you could also access that using like the current node dot next. And the other thing that you'll keep a track of is like the very first critical point index that we've seen and the most recently seen critical node index. And these four should be enough to solve the problem. So let's get started to see how exactly it works out. Okay, so let's start with the nodes that we have to keep track of, right? So list node previous, right? So let's just start with head. Right? Yeah, so head and list node current would be equal to head dot next. So basically this is where we will keep so basically we're looking at the previous node and the current node. The next node, basically we can access it by looking at current dot next, right? So these are the only two list node pointers that we need. The other thing that we need is the two indexes. So let's say int first seen critical index. So let's just initialize this to -1 because we don't know. And int most recently seen critical index would also be equal to -1, right? And I think like the last thing we need is to actually keep a track of the current index, because basically when we move from, okay, so A to B to C to D, right? So we need to know what index that node is at, but since linked lists, list node lists don't really have indexes, so we need to keep a track of them manually. And since we'll be starting with this particular node, we can start off with 1. So let's get started. We need to basically have a while loop, and this will keep going till the current node, like the next node, is not equal to null. While the next node is not equal to null, you need to check for two things. So if there are two conditions, if it is a minimum, like a local minima or a local maxima. So let's try for local maxima first. So what does that look like? So if current dot value is greater than previous dot value, and current dot value is greater than current dot next dot value, so this condition will look for the local maxima, and the next condition will look for the local minima. So basically, we need to copy over the same thing, but change that to be the minimum, right? So if we have found a point like this, it means we have reached a local minima or a local maxima, and we need to assign it to either this or this, right? So if the first seen critical index is still equal to -1, that means we still haven't seen any critical nodes, and you will basically assign this to be the index. If it's already has been occupied by a value, we basically need to update like the most recently seen critical index, right? And this is where we set the minimum. And we don't really have a minimum here, so let's do that right now. So int minimum would be equal to integer dot max underscore value. In this case, it'll be minimum equals to mat dot minimum of the of the minimum value that we've seen previously, or it will be the current index minus like the most recently seen critical index. So basically what you're saying, we've reached a point where there's another critical node right here. So compare this with the most recently one that we've seen previously, and then try to calculate if this gives us the minimum. So that's when you update it. And once that is done, the most recently seen critical index will be updated to index itself. Awesome. So once we get out of that if loop, there are a few things that we need to do. Previous will become equal to current. Current will point to the next node, current.next. And the other thing, the last thing that I think we need to do is increase the index. So that should take care of looping through the while loop. And once it exits the while loop, there are two conditions that we need to check. Actually, let's do this. If the minimum is still equal to integer.max value, that basically means that we haven't found any critical nodes in the list that's been given to us. So we would just return the default values, which is new int -1 -1. If this hasn't been returned as of yet, that means we do have values. So we would do new int. So we need to populate it with the minimum and the maximum value. We have been keeping a track of the minimum value here, right? So it will be minimum. And the maximum will be basically the most recently seen critical index. So after it exits the while loop, the most recently seen critical index will be the last one that we have seen. So this is basically, once you exit the loop, the most recently seen critical index will be the last one that we have seen. And we have already stored the first seen critical index, and we haven't touched it ever since this part, right? So this will give us the maximum distance between those two. So that should basically solve the problem. Let's try compiling this. Okay, the first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the entire solution. The time complexity of the entire solution is of n, since we have to iterate through all of the nodes that are given to us, and the space complexity is of 1. Since we're not really using any like space that's necessarily growing with the problem as we solve the problem, it's just like using constant space. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate that. Thanks so much, and I'll see you folks soon. Peace.